All right, Karan, I went all the way through class and never recorded this, so I'm going to have to record it for you separately. Ian, will you get me a set of sequence notes that's blank from up there? All right. Sequences are numbers, is basically a list of numbers that have a relationship. A sequence can be portrayed with a set of pictures or a set of numbers. Oftentimes, a test question will have a set of pictures and questions that will equation reflects this relationship. So what they're wanting you to do is use the example below and make a table of values using 1, 2, 3, 4, or is how many pictures you have for your x. Then enter your y values, count the number of things in the first picture, second picture, third picture, and then it's probably going to be easier for me to just flip the page with you and we'll do the next one together. Okay? If the pattern continues, which expression can be used to find the number of circles that make up figure n? Okay, well, we've got a table here that we can fill out. This is our first picture, our second picture, our third picture, our fourth picture, our fifth picture. So here in my x values, I have 1, 2, 3, 4, 5. Okay, so what I need to do is to count how many are in each one. So in my first figure, I have 3. My second figure, I have 8. My third figure, I have 15. My fourth figure, I have 24. And my last figure, I have 35. Okay? So I need to figure out which one of these equations will give me each of these if I substitute. And x is your n, which is your term number. N represents term, the position, I want to say. The position the term is in the sequence. So in other words, this figure is in the first position. That's why it's N1. So we're going to check these, but you have to make sure you check all of them. So if I start with A, I have n squared plus 2n. So if I put a 1 in, 1 squared plus 2 times 1, I get 3. If I put 2 squared plus 2 times 2, I get 8. 3 squared plus 2 times 3, and I get 15. 4 squared plus 2 times 4, and I get 24. 5 squared plus 2 times 5 would give me 35. So obviously A is my answer choice. But you need to be careful that you're checking each one of these. You need to check each term because look at what happens when I try B. N squared plus 2. If I was to put in 1 squared plus 2, I actually get 3, don't I? And if I was the lazy type of person, I'd say, oh, I've got the answer. But if I put in 2 squared plus 2, I get 4 plus 2, which is 6. So that is where it wouldn't work because my second term is 8. So you have to check for each term in the sequence. All right, this one is if a pattern continues, which expression can be used to find the number of shapes. So the same thing here. Remember that your x, or this is your n values. It is the position. So n equals 1, n equals 2, n equals 3, n equals 4. This is the first position in the sequence, second, third, and fourth. And you can do it that way, or you can make a table, whatever you're more comfortable doing. Then I need to count how many is in each picture. So I've got 5 here, I've got 8 here, 11 here, 14 here. I'm going to put those in my table just because that is the way that is suggested you do it. I probably do it this way. Now I'm going to try my different and see if I can get one to match. So if I look at A, I have n plus 2n. So I'm going to substitute my x value and try and see if I get a y. So 1 plus 2 times 1 gives me what? 2, 3. I do not get my y, so it cannot be A. B is n plus 3. So if I substitute 1 in for n plus 3, I get 4. I need a 5, so that's not it. How about C? 3n plus 2. So now I'm going to put in 3 times 1 plus 2, which gives me 5. Okay, I've got my first number. 3 times 2 plus 2, which gives me 8. I got my second number. 3 times 3 plus 2 gives me 11. I've got my third number. 3 times 4 plus 2 gives me what? It gives me 14. So that is my last number, and that would be my answer choice. All right. We also have sequences that are given to us in what's called the recursive form. Okay? And the recursive form is a formal definition that is the form expresses each new term of a sequence based on the preceding term. In other words, the next term is based on doing something to the term before it. So we have arithmetic sequences, which is adding something to the previous term, or geometric sequences, which is multiplying by something to the previous term. And that's what this says down here. So let's flip the page and try one. A of n is equal to a of n minus 1 plus 7. Okay? A of 1 is saying this is the first term in the sequence. Okay? So this is your n, and this is your a value. Okay? So if I want to do a of 1 is the first term in the sequence, and if you notice, if I take a of n minus 1 plus 7, I can substitute the second term here, a of 2 minus 1 plus 7, and I would get a of 1 plus 7 would give me, this is for a of 2 equals, a of 2 would equal, take your first term, which is 2, and put it in your adding 7, your plus 7, and you would get 9. And I could find out what any term of this sequence is each time you're taking the previous term and you're adding 7. Okay, so the first number is 2, the second number is 2 plus 7, which is 9, the third number is 9 plus 7, which is 16, and the fourth number is 16 plus 7, which is 23. All right, let's do one more practice, and then you have the practice pages today. We are going to be doing those in class tomorrow. I've told the class, well, I'll talk to you in just a minute. So we have example 2, which I had the students do in class, where if you have 4a times n minus 1, okay, remember this is your n and this is your a, okay, so what it's telling you is take the previous term, which is this, and multiply it times 4. So obviously, if my first term is 6, because that's what it told me here, a of 1 equals 6, how can I find a of 4? Well, I can take this formula, 4a times n minus 1, and all I'd have to do is plug in 4a times, what is it? 4. I want the fourth term minus 1. I need to take 4 and multiply it times a of 3. Sorry, a of 3. Well, what was a of 3? A of 3 was 96. So I can do 4 times 96 and find out that the fourth term is 384. And that's all there is to this. Quran, there is a practice for you to do. You should be able to do it pretty easily with these notes. What is going to be happening this week is I'm not giving any homework. I'm going to be sending you a test on exponentials that you've already taken, but that will be your review over exponentials. We'll be working on that in class. So I don't know that I will be giving you that review. Hopefully you still have your notes on exponentials. Otherwise, I believe, I don't remember if I have some videos on exponentials. I probably do. You can go back to Google Classroom over exponentials. And then we are going to be bringing up packet questions to class that we want to have help with. So if you come up with any of those, email me those and I'll put those on a video. All right, have a great week. Talk to you later.